Now let's see a brief this thing about what are the advantages and disadvantages between the three basic types, the fixed tube sheet, U-tube, or the floating head types. So if you take the U-tube type, these are the pros. It has straight tubes. But it's a non-removable bundle. It's one of the most cheapest, the most economical cost-wise. It's easy to clean on the tube side, and you can have either even or odd passes design on the tube side. The disadvantages: mechanical cleaning is not possible on the shell since there is no access. And this means that you need to locate the fluid with the lesser fouling tendency on the shell side. It's not possible to replace the tube bundle, and large temperature differences can lead to using of expansion joints. Coming to a U-tube heat exchanger, there is a removable tube bundle. It can handle differential thermal expansion and thermal shock applications. It's possible to replace the tube bundle alone. Mechanical cleaning, the cons would be mechanical cleaning inside the tubes is difficult. So we should allocate fluids which have lower fouling tendency on the tube side in this case. Higher temperature differential across the tube sheet may lead to distortion of the tube sheet. And because of the U-tube construction, they're limited to only even pass designs. Then a floating head unit. Your pros would be it is a removable tube bundle. You can remove the tube bundle, replace only the tube bundle. It's easy for inspection and cleaning because it's a removable bundle. Then it can handle differential thermal expansion and there's no need for any expansion joints. The cons: it is the most expensive among all these three types, and it's generally limited to only even pass designs. Because if you have an odd pass design on a floating head exchanger, you need a fluid outlet on the tube side at the floating head. On the floating dish, you need a outlet. And that being an internal component, you will again need an expansion joint between the floating head and the shell cover to ensure that there is no stress on that at the dish junction. Now, fluid allocation is very important because it plays a major role in your design, how in the size of the unit, which again directly impacts the cost of the unit. Fluid allocation depends on many factors. A few of them are fluid characteristics, like the fluid can be with high viscosity. Then on which side should the fluid go? If one of the fluids is slurry or has suspended solids, where should we put it? Should we put it on the shell side or on the tube side? Then we have the operating conditions which can influence your decision on fluid allocation. Fluid with a high flow rate, fluid with a high pressure or low pressure drops or high temperature difference. Then you can have factors which are based on fouling or on cleaning requirements. Then you have factors based on material selection. Sometimes you may have exotic materials because of the nature of the fluid which you are handling. Then which fluid should go into which side. So all these factors will affect how you do the fluid allocation.